We have reached chapter 12, liquids, solids, and intermolecular forces. This is kind of an interesting quote from Roald Hoffmann. It's a wild dance floor there at the molecular level. So we're going to be looking at what the molecules are doing in liquids and solids. We're going to start off by watching a video about water in zero gravity.
The question is, if you get a cloth dripping wet without gravity and you wring it out, what's going to happen? What will happen to a wrung out cloth? Soap. And had you used equipment that was here on board the space station, we might have the coolest washcloths ever here on the space station. I'm going to show you. Here's one of our washcloths. And it's packed in. It's put down into this little tiny hockey puck so that it saves space. But when you open up a hockey puck and you pull out your washcloth, this is the one I'm going to use for the experiment today. So when you open up your hockey puck and turn it into a washcloth, it was compressed in a great big vise somewhere. Okay, so here's my washcloth, like a magic trick. And now I'm going to get this soaking wet, and then we're going to see what will happen when we wring it out. Meredith and Kendra suggested that I dip this in a bag, but bags don't hold water in space, so instead I filled a water bag. This has drinking water in it. And I'm going to squirt a bunch of water into this washcloth. Okay, so here's a soaking wet washcloth. Get the microphone so you can hear me while I'm talking. And now let's start wringing it out. It's really wet.
That's not what happens on Earth, is it?
It's becoming a tube of water. The water's all over my hands. In fact, it rings out of the cloth into my hands. And if I let go of the cloth carefully, the water sort of doesn't stick to my hand. Okay, so the experiment worked beautifully. And the answer to the question is the water squeezes out of the cloth, and then because of the surface tension of the water, it actually runs along the surface of the cloth and then up into my hand, almost like you had Jell-O on your hands or gel in your hand, and it'll just stay there. Wonderful moisturizer on my hands. And the cloth doesn't really unravel itself. It just stays there floating like a dog's chew toy, soaking wet. Great experiment, worked perfectly. Meredith and Kendra, congratulations, great idea.
Nope.
Nope. Not today, sir. Okay. Anybody have any questions about that? That's different, huh? Well, we're going to talk today about what causes water to do that. He mentioned surface tension, and so we're going to be talking about intermolecular forces, which are responsible for surface tension. Intermolecular forces are the forces of attraction between molecules, and these also occur between atoms. All atoms and molecules experience intermolecular forces. They're significant only at very short distances. They are responsible for the existence of liquids and solids. If there were no intermolecular forces, we wouldn't have very many liquids or solids. They would all just be a gas. Intermolecular forces are also essential for physiological processes, So if you're more interested in the biology side of science, intermolecular forces are very important there as well. We will see that the state of a sample, whether it's a solid, liquid, or a gas at a given temperature, depends on the strength of the intermolecular forces relative to the amount of thermal energy. The amount of thermal energy is determined by the temperature.